Good morning, part two of polygons today. So I reminded you last time that a polygon is a two-dimensional shape with straight sides. And we talked about two sorts of angles, didn't we? So we've got here's a polygon, it's 1, 2, 3, 4, 5, it's a pentagon, 5 sides. We've got angles inside the shape, which I've referred to as interior angles, and a pentagon has 5 interior angles. And we talked about the angles outside the shape, which we referred to as exterior angles. And it's important to remember that when we talk about exterior angles, we're talking about this angle here, not an angle like this. These angles here don't actually have a name. So an exterior angle and an interior angle at any corner add up to 180 degrees, not 360. Now this is not a regular polygon. Its sides are not all the same length, but if it is a regular polygon, its sides are the same length, and that means that each of the interior angles are all the same size, and each of the exterior angles are also the same size. And we had a set of questions last time on exterior angles. So this is sort of where we're going with this. I really want to be able to sort of fill in this table today. I want to be able to talk about the interior and exterior angles of any polygon, and in particular regular polygons. So the last video we had that little graphic of me drawing a shape on the school field, and hopefully you're convinced that the exterior angles, these angles here, for any polygon always add up to 360. And if it's a regular polygon, then they're all the same size. So if it's got n sides, that's 360 divided by n. So 8 sides, 360 divided by 8, 12 sides, 360 divided by 12, etc., etc. That shows you how big each exterior angle is. So today I want to talk about the interior angles and see if we can get some idea about what the total of the interior angles are in any polygon, and therefore how big they are if it's a regular polygon. Okay, so let's talk about interior angles. I've drawn here a triangle, 3-sided polygon, a quadrilateral, 4-sided polygon, and a pentagon, 5-sided polygon. They're not regular, just common or garden ones. And we already know some stuff. Now this is version 2 because I've made a mistake here. If you were in class, then there would be bourbons given out plenty. A triangle, we know the angles inside in a triangle add up to 180 degrees. In version 1 it was 360, I don't know what I was thinking. We also hopefully know, and I mentioned it in the last video, that any quadrilateral, the interior angles add up to 360. And already there's a sort of fledgling pattern appearing there, and I'll tell you that every time you add an extra side, the total of the interior angles goes up by 180 degrees. So in my pentagon, I know it's going to be 540 because that is 360 plus 180. Go on, prove it, I hear you say. Okay, I'm going to prove it. I'm going to pick one corner in my pentagon, and I'm going to join that corner to other corners that it's not joined to. Now here we go. So it's already joined to that corner, so I don't need to draw a line in. I'm going to join it to that corner, and I'm going to join it to that corner. Now that creates 1, 2, 3 triangles, and if I look at the angles in those triangles, there's the angles in that triangle, and there's the angles in that triangle, and there's the angles in that triangle. The angles in those 3 triangles together give me all of the interior angles in that pentagon. And so I know that the angles in a pentagon add up to 3 lots of 180, and 3 lots of 180 is 540. Let's keep going. Okay, so going from a 5-sided shape to a 6-sided shape, we're just adding another 180 degrees. So that gives me 720 degrees. Go on, prove it, I hear you say. Well, no, you prove it. Just pause the video at this point. Draw me a hexagon So it doesn't have to be regular, but this is a pentagon because it's got 5 straight sides. Draw me a shape made up of 6 straight sides. Pick a corner and do my little diagonal trick and just check that it makes 720 degrees. Okay, so here's a hexagon, just a shape made up of 6 straight sides. Picked a corner, going to join that corner to any corners that it's not already joined to. How many triangles? 1, 2, 3, 4. Guess what 4 times 180 is? It's 720. And so that pattern carries on. The only trouble is, if I said, okay, what's the total of the interior angles in a 20-sided shape, it's a bit of a pain to keep going through adding 180. So I don't know if you've spotted another pattern. A quadrilateral, I didn't do it for the quadrilateral because it was a fact we already knew, but that can be split into 2 triangles. 2 times 180 is 360. So 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. And the pattern is this, that if you have any polygon, where n is the number of sides, if you want to know how many triangles, it's n take away 2, the number of sides take away 2, that's how many triangles. So that is the rule that we use to work out the total of the interior angles in any polygon. It's the number of sides take away 2 times 180. Although if it's just a small number of sides, you can do my adding 180 trick. Start with a triangle and realise that every time you add a side, you're adding 180 degrees. So returning to my little summary table, we can say the interior angles in any polygon add up to the number of sides take away 2 times 180. So if it's a 7-sided polygon, I do 7 take away 2, 5, lots of 180, and that tells me what the angles inside are going to add up to. If it's a regular polygon, all of those are the same size, so that's what the total is. All I do is divide that by the number of sides. Now that looks like a horrible calculation. We better do an example just to make sure that you understand how to do that. But that table is certainly something which I think is worth having in your notes. So here are 3 sample questions, and then I've attached a set of questions for you to try. And as always, if you can do these 3, you'll be able to do the 3 that the questions on the sheet. Answers on the second page as always. Still waiting for some people to submit from last week. That's going to save me phone calls. If you get that done, please crack on with that. Okay, so the total of the interior angles in a decagon. So remember that rule, number of sides take away 2 times 180. A decagon is 10 sides. So 10 take away 2, it's going to be 8 times 180, and 8 times 180 is 1,440. So that is what the angles inside a decagon, a 10-sided polygon, add up to. Okay, question 2, how big is each interior angle in a regular nonagon? So this wasn't a regular decagon, it was just any old shape with 10 straight sides. Now we're talking about a regular nonagon. Nonagon is 9 sides. So let's firstly work out what those angles would add up to, what the total would be. Same rule, 9 sides, n take away 2, 9 take away 2, 7 triangles. 7 times 180, which is 1,260. And that sort of confirms the other way of doing it, because every time you add a side, so going from 9 sides to 10 sides, you've added 180. So that's what the angles inside the nonagon will add up to. But this is a regular nonagon, so they're all going to be the same. So all I need to do to work out the size of each angle is take that total and divide it by 9, because a nonagon, 9 sides, it'll have 9 interior angles. So 1,260 divided by 9, 1,260 divided by 9, it's 140. So that means in a regular nonagon, every angle inside the shape is going to be 140. Okay, final question. Here's a shape. I've got some angles I know and one angle I don't know. Firstly, I'm going to work out how many sides it's got. So I think it's really easy to make a mistake here. So I'm going to start counting here. So that's 1, 2, 3, 4, 5, 6 sides. Okay, 6 sides. It's not regular, but I know that in any polygon with 6 sides, the total of the angles will be 2 less than that, 4 triangles worth. 4 times 180, and that's 720. Okay, what do the angles I know add up to? Okay, so I get my calculator out. So I'm going to start here again. So I'm going to do 50 plus 160 plus 95 plus 115 plus 45, 465. So the missing angle x is whatever you need to add to 475 to make 720. So it's 720 take away 465. So 720 take away 465. That gives me 255 degrees. That sort of makes sense because this is bigger than 180 degrees, isn't it? And there we go. That's the missing angle there. So today we've been talking about interior angles, and the attached worksheet is questions along those lines. And I hope you are all well.